Hi guys, welcome to my channel. In this video we are going to analyze the questions about the structural analysis. The question will be analyzed due to the slope deflection method, and in the question there is a sideway, so we are going to the calculation the deflection also. Okay, so now let's solve the question. First I'm going to specify the fixed end moment from A to B. Fixed end moment from A to B, that will be WL square equal 12. So WL square, it will be 10 times 8 square over 12, and that will be minus also, because from A to B, minus 53.33 kilonewton meter. From BA, that will be also equal to this value, because you know it's the same. And from BC, it will be 0. It's also be equal to CB. Okay. So now let's write the moment equations. Moment AB. Now I have moment AB 2EI over 8 times 2 theta A plus theta B minus 3 delta over L, but L is 8. Because the deflection happens in the fix. So now minus 53.33 is equal to, I don't know, we are going to specify BA 2EI over 8 times 2 theta B plus theta A minus 3 delta over 8 and plus 53.33. This is my also value. And for BC, for moment BC, I'm going to use the modified formula. So 3EI over 6 times 2 theta B. Sorry, that will be not 2 theta B, that will be just theta B. Theta B and minus delta over L. And of course minus fixed moment, 0. So now in this question, you know, I don't need to calculate the theta A and delta for the BC. I'm just going to calculate theta B and delta for BA and AB. So now let's write it, you know, for the moment BA and plus moment BC is equal to 0, right? Everyone knows that. So I'm going to write the equation here. That will be 4EI theta B over 8 minus 6EI delta over 64 and plus 53.33 and plus 6EI theta B over 6. So 3EI theta B over 6 and equal to 0. And now, you know, we have two unknowns and one equation. So I need another equation to solve the question. 1 second. So I need another equation. How I'm going to find it? I'm going to find this equation from the shears. For example, now I have this is my column part. Okay, I have an AX and I have a point. I convert it to point load as 80 kilonewton, and this is my, for example, BA. This is my AB moment. Okay, now in this how I'm going to find AX, you know, finding AX high, AT is equal to AX also, actually, and it's going to be something like that. The moment AB plus moment BA plus, due to respect to B, okay, this is point B, this is point A, so that will be AT times 4, this is, you know, 8 meters, so it's going to be 4, and over the length of the beam, okay, length of the column, 8. In this equation, I am going to obtain that moment AB plus moment BA equal to 320, right? If it is equal to this, now let's write the moment BA and AB equation. For moment BA, I'm going to, start with AB, 3EI theta B over 8, okay? And minus 6EI delta over 64, and minus 53.33. For BA, that will be plus 4EI theta B over 8, and minus 6EI delta over 64, and plus 53.33 is equal to 320. Now, you know that this is my negative, this is positive, so they will cancel each other. And from this equation, I'm going to obtain this. 2EI theta over 8 and 4EI theta over 8, that will be 6EI theta B over 8 minus 12EI delta over 64 is equal to 320. And I have also an equation, and before the first equation I obtained from the moment BA and plus moment BC is equal to 0. What was that? That was also, this is you can see 0.5, okay? This is also 0.5, so I have this is 0.5, sorry, the summation of them also it will be 1, so I will write back theta B, that will be minus 6EI delta over 64 is equal to minus 53.33. And now I have these two equations. If I have two equations and two unknowns, so it's easy to solve it. Now when I solve this equation, I'm going to obtain theta B as 300 minus 341.328 over EI, and also I will obtain as delta value as minus 3071.978 over EI. I guess now it's okay. I'm going to write its own place and determine the moments. The moments will be 149.335 kilonewton meter, and for the bottom that will be for BA that will be 17066 kilonewton meter, and also for BC that will be minus 17.66 kilonewton meter. Sorry, I really like that. So now you can see I have the moments. So I have moments, I'm going to obtain the shears. I actually obtain a shear here, you can see, AX. And now I'm going to find for the second member. Okay, the second member is something like that. You can see there's a moment here, 1766, and there is also CY, and also I have BY, right? So yeah, if I have like that, I'm going to draw it now. I'm going to take the moment with respect to B. Okay, total moment at B is equal to 0. And now I'm going to solve this. CY times 6, this is 6 meter, okay? And minus, yes, because it's going to be downward. It's going to be downward direction. I'm sorry, this is going to be downward direction. First, you know that we specify the directions. We specify the direction as we know, as we want. Then we are going to obtain that our moment is show that the direction of the shear. Okay. Now this is positive way actually. And now I am going to obtain the Cy as minus 28.44. Okay, and for By is be equal to that, but the positive of that. Now I obtain the all shears. If I obtain the shears, let's draw the moment and the shear diagrams. I'm going to draw the moment and shear diagrams here because I can't fit it in that place. I am going to draw them one by one. The first element, A to B. Now I have as 80 shear at B. Okay, I'm going to raise up at 80, and then I'm going to get down. I'm going to go down as 80 because of the distributed load. 80. Now this is for the first part. Now let's draw the moment diagram also for this part. And for now, I have a moment as 149.335. Okay, then I will goes up 149.335. Okay, I will goes down with this amount of area. Okay, this amount of area. What is this amount of area? This is 8. What is this amount of area? This is 320. Okay, when I goes down with this amount of area, that will be something like that. It will be 1766. Right, 1766. This is for the first part. So let's draw the next part. For the next part, I have a shear here as 28.44, and I will continue with 28.44, until the other support. And you know, this is the downward direction. I told you that this is the downward direction, and it will close at this point. I don't need to write it also because I will close it and close it. And for this one, the moment, I will take the same value of the moment here because, you know, it will going to be carried to the other elements. I'm going to take the same value. Okay, I have an also moment here. I will go on at the same amount of area, 76. I have as 17.66. If I goes up at this amount of area, and I'm going to decrease it because it's going to be, if it is rectangular, the shear, the moment will be triangular. I will goes up at this amount, and that will close. Why that will close? Because there is no any moment at C. We calculated before. There is no any moment at C. And the area of this, that will show me that how much I'm going to decrease. Okay? And now the question is that, thank you for watching me. If you like these videos, please subscribe and share with your friends, comment.